Hello students, my name is Arshan and today we will do the 4th chapter of your mathematics textbook of NCERT of class 7th. The name of the chapter is Simple Equations. Students, this brings us to the segment that is solving an equation. Consider an equality, that is 8 minus 3 is equals to 4 plus 1. The equality holds since both its sides are equal. Each is equals to 5. Let us now add 2 to both sides. As a result, LHS will be 8 minus 3, that plus 2 equals to 5 plus 2 equals to 7, and RHS will be 4 plus 1 plus 2 equals to 5 plus 2 equals to 7. Again the equality holds, that is its LHS and RHS are equal. Thus, if we add the same number to both sides of an equality, it still holds. Let us now subtract 2 from both the sides. As a result, LHS is equals to 8 minus 3 minus 2 is equals to 5 minus 2 is equals to 3. And RHS will be 4 plus 1 minus 2 is equals to 5 minus 2 is equals to 3. Again, the equality holds. Thus, if we subtract the same numbers from both sides of an equality, it still holds. Similarly, if we multiply or divide both sides of the equality by the same non-zero number, it still holds. For example, let us multiply both the sides of equality by 3. What we will get as an LHS? We will get 3 multiplied by 8 minus 3 is equals to 3 into 5 is equals to 15. Now in the RHS we will see 3 multiplied by 4 plus 1 is equals to 3 into 5 is equals to 15. Therefore, the equality holds. Let us now divide both sides of equality by 2. So the LHS will be 8 minus 3 divided by 2, which is equals to 5 divided by 2, which is equals to 5 by 2. And what will be the RHS then? RHS will be 4 plus 1 divided by 2, which is equals to 5 divided by 2, which will be 5 by 2. That is LHS. Again, the equality holds. If we take any other equality, we shall find the same conclusions. Suppose we do not observe these rules. Specifically, suppose we add different numbers to the two sides of an equality, we shall find in this case that the equality does not hold. That is, its both sides are not equal. For example, let us again take equality. 8 minus 3 is equals to 4 plus 1. Now add 2 to the LHS and 3 to the RHS, that is right hand side. The new LHS will be 8 minus 3 plus 2 is equals to 5 plus 2 is equals to 7, and the new RHS will be 4 plus 1 plus 3 is equals to 5 plus 3 is equals to 8. The equality does not hold because the new LHS and RHS are not equal. Thus, if we fail to do the same mathematical operation with same number on both sides of an equality, the equality may not hold. The equality that involves variable is an equation. These conclusions are also valid for equations, as in each equation variable represents a number only. Often an equation is said to be like a weighing balance. Doing a mathematical operation or an equation is like adding weights or removing weights from the pans of the weighing balance. An equation is like a weighing balance with equal weights on both its pans, in which case the arms of the balance is exactly horizontal. If we add the same weights to both the pans, the arm remains horizontal. Similarly, if we remove the same weights from both the pans, the arm remains horizontal. On the other hand, if we add different weights to the pens or remove different weights from them, the balance is tilted. That is, the arm of the balance does not remain horizontal. We use this principle for solving an equation. Here, of course, the balance is imaginary and numbers can be used as weights that can be physically balanced against each other. This is the real purpose in presenting the principle. Let us now take some examples. Now consider this equation: x plus 3 is equals to 8. Now when we subtract 3 from both sides of this equation, the new LHS is x plus 3 minus 3 is equals to x, and the new RHS is 8 minus 3 is equals to 5. Since this does not disturb the balance, we have new LHS equals to RHS, or x is equals to 5, which is exactly what we want as the solution of the equation. To confirm whether we are right, we shall put x is equals to 5 in the original equation. We get LHS is equals to x plus 3 is equals to 5 plus 3 is equal to 8, which is equal to the RHS as required. By doing the right mathematical operation, that is subtracting 3 on both the sides of the equation, we arrived at the solution of the equation. Now let us look at another example. The equation is x minus 3 is equals to 10. What should we do here? We should add 3 to both the sides. By doing so, we shall retain the balance, and also the LHS will be reduced to just x. New LHS is equals to x, cos minus 3 plus 3 is equals to x, and the new RHS will be 10 plus 3 is equals to 13. Therefore, x is equals to 13, which is the required solution. By putting x is equals to 13 in the original solution, we confirm that the solution is correct. LHS of original equation is equals to x minus 3 is equals to 13 minus 3 is equals to 10. This is equal to the RHS as required. Let us do example number 5. The first equation is 3n plus 7 is equals to 25. For the solution of this equation, the LHS is 3n plus 7 and the RHS is 25. We shall first subtract 7 from the LHS so that we can get 3n. After this, in the next step, we shall divide by 3 to get n. We must also remember that we must do the operation on both the sides. So the equation is 3n plus 7 minus 7 is equals to 25 minus 7, which leaves us to 3n is equals to 18. Now we divide both the sides by 3. This gives us the equation 3n by 3 is equals to 18 by 3. Therefore, the solution is n is equals to 6. One good practice you should develop is to check the solutions that you have obtained. Now students, we are in the position to go back to the mind reading game presented by Appu, Sarita and Amina in the starting of this chapter and understand how they got their answers. For this purpose, we will look at the initial equations of Appu and Amina. Considering the first equation, that is 4x plus 5 is equals to 65, subtracting 5 from both the sides, 4x plus 5 minus 5 is equals to 65 minus 5, that is 4x is equals to 60. Now dividing both sides by 4, this will separate x. We will get 4x divided by 4 is equals to 60 by 4. Hence we will get the solution, that is x is equals to 15, which is correct. Now considering another equation of Appu, that was 10y minus 20 is equals to 50. Adding 20 to both sides, we get 10y minus 20 plus 20 is equals to 50 plus 20, or 10y is equals to 70. Now we will divide both sides by 10. We get 10y divided by 10 is equals to 70 by 10. After solving further, we will get y is equals to 7, which is the solution. We can check it also if it's correct or not. we will realize that exactly these were the answers given by Appu, Sarita and Amina. They had learned to set up equations and solve them. That is why they could construct their mind reader game and impress the whole class. We shall come back to this section. So students, we will solve the equations in the similar fashion. Now, coming on to the next topic, that is more equations. Let us practice solving some more equations. While solving these equations, we shall learn about transposing a number, that is, moving it from one side to the other. We can transpose a number instead of adding or subtracting it from both sides of the equation. See this example, students. The equation is 12p minus 5 is equals to 25. Now, to solve it, what we will do? We will add 5 on both the sides of the equation, which will bring us to 12p minus 5 plus 5 is equals to 25 plus 5, or 12p is equals to 30. Now, we will divide both sides by 12. Therefore, 12p divided by 12 is equals to 30 divided by 12, or p is equals to 5 by 2. Now, we will check it. We will put 5 by 2 in the LHS of the equation once again. So, the LHS will be 12 multiplied by 5 by 2 minus 5 is equals to 6 into 5 minus 5 is equals to 30 minus 5 is equals to 25, which is RHS. Hence, it is proved. As we have seen, while solving equations, one commonly used operation is adding or subtracting the same number on both sides of the equation. Now, transposing a number, that is changing the sides of the number, is the same as adding or subtracting the number from both sides. In doing so, the sign of the number has to be changed. What applies to numbers also applies to expression. Let us take two more examples of transposing. The first example is 3p minus 10 is equals to 5. Now we will add 10 to both sides, which will bring us to 3p minus 10 plus 10 is equals to 5 plus 10, or 3p is equals to 5. If we do the transposing of this, we will do 3p minus 10 is equals to 5, transposing minus 10 from LHS to RHS. On transposing, minus 10 becomes plus 10, which will bring us to 3p is equals to 5 plus 10, or 3p is equals to 15. So you see, students, the answer is same. Hence, we can try transposing method also. Now, we shall solve two more equations so that we can see the involvement of brackets which have to be solved before proceeding. So, see the example 7. The first question is 4 in the bracket m plus 3 is equals to 18. First, we will divide both the sides by 4. For this, we will remove the brackets. In the LHS, we get 4 plus 3 is equals to 18 by 4, or m plus 3 is equals to 9 by 2, which will further be simplified to m is equals to 9 by 2 minus 3. We have transposed 3. So, the required solution is m is equals to 3 by 2. Now, students, let us go on to the another topic, that is solution to equation. Atul is a kid just like you people, but he thinks differently. He looks at successive steps that one takes to solve an equation. He wonders why not follow the reverse path, that is, equation solution is the normal path and solution equation the reverse path. He follows the path given below. Start with x is equals to 5. Now multiply both sides by 4, that is 4x is equals to 20. Then divide both sides by 4. Then subtract 3 from both sides. Hence we get the equation as 4x minus 3 is equals to 17. This has resulted in an equation. Now if we follow the reverse path, what we will get? Adding 3 to both sides, then dividing the both sides by 4, we will get the answer as x is equals to 5. So children, another student, Hetal, she also felt interested after seeing what Atul did. So she starts with the same step and builds up another equation. What she did, she took the equation x is equals to 5. She multiplied both sides by 3, after which we get 3x is equals to 5. Then she add 4 to both sides. Then we get 3x plus 4 is equals to 19. Now students, you can start with y is equals to 4 and you can make two different equations and write it down in your notebook. In the same fashion students, now Sarah wants the class to know what she is thinking. She says, I shall take Hetal's equation and put it into a statement form, and that makes a puzzle. For example, think of a number, multiply it by 3 and add 4 to the product. Tell me the sum you get. If the sum is 19, then the equation that Hetal got will give us the solution to the puzzle. In fact, we know it is, because Hetal started with it. She turns to Appu, Ameena and Sarita to check whether they made their puzzle this way. All three of them said yes. Now we know how to create number puzzles and many other similar problems. This brings the students to exercise 4.3. The first question is solving the equations. We will solve these equations in the similar fashion in which we did our examples. The first question is 2y plus 5 by 2 is equals to 37 by 2. We can solve this equation, students, by following various methods. First, we will transpose the 5 by 2, which will brings us to 2y is equals to 37 by 2 minus 5 by 2, which is equals to 2y is equals to 32 by 2, which will be further solved to 2y is equals to 16, which will be solved to y is equals to 8. Hence, 8 is the answer. You can further check it out also. This bringing us on to the second question by solving another equation. Now, take in account this question, which is 2 in the bracket x plus 4 is equals to 12, which will be equal to 2x plus 8 is equals to 12. Now, following the similar steps, 2x is equals to 12 minus 8. 2x is equals to 4. Hence, x is equals to 2. This will be the answer. Going on to the third question, and the first part of that question is 4 is equals to 5p minus 2. We will take 4 is equals to 5p minus 10 equals to 4 plus 10 is equals to 5p equals to 14 is equals to 5p, which will be equal to 14 by 5 is equals to p. Check this answer also. After this, students, we are on the interesting topic of application of simple equations into the practical situations. So, we have seen examples in which we have taken statements in everyday language and converted them into simple equations. We also have learned how to solve simple equations. Thus, we are ready to solve puzzles, problems from practical situations. The method is first to form equations corresponding to such situation and then to solve those equations to give the solution to the puzzle or problem. We begin with what we have already seen in the example first. So, taking into account the example number 8. The sum of 3 times a number and 11 is 32. Find the number. To find the solution of this question, students, what we will do? We will take the unknown number as x, then 3 times the number will be 3x, and the sum of 3x is and 11 is 32. Then the equation will be 3x plus 11 is equals to 32. To solve this equation, we transpose 11 to right hand side or RHS, which will give us 3x equals to 32 minus 11 or 3x equals to 21. Now dividing both sides by 3, we will get x is equals to 21 by 3 is equals to 7. Hence the required number is 7. Easy, isn't it? Let us go on to another example, example number 9. The question is, find a number such that 1/4 of the number is 3 more than 7. Now let us take the unknown number to be y. 1/4 of y is y divided by 4 or y by 4. This number y by 4 is more than 7 by 3. Hence we get the equation as y by 4 minus 7 is equals to 3. To solve this equation, we will transpose 7 to right hand side or RHS. We will get y by 4 is equals to 3 plus 7 is equals to 10. Now we will multiply both of these equations by 4. So we will get y by 4 into 4 is equals to 10 multiplied by 4, or y is equals to 40. We can check this number also. This is the required solution. Going on to the example number 10. The question is, Raju's father's age is 5 years more than 3 times Raju's age. Find Raju's age if his father is 44 years old. Now, it is clear that Raju's age is 3y plus 5 is equals to 44. To solve it, we will transpose 5 to get 3y is equals to 44 minus 5, which is equals to 39. And then dividing both sides by 3, we get y is equals to 13. Raju's age is 13. So students, after doing all these examples, we are on to the exercise 4.4. The first question is setting up the equations and solving them to find the unknown numbers. So students, we will take the first question, that is solving up the equations and finding the answer. The first question is, add 4 to 8 times a number, you get 60. Students, we will take the number as x. Now the question is saying to add 4 to 8 times a number, which is equals to 8x plus 4 is equals to 60. Now to solve this equation, 8x plus 4 is equals to 60, we will transpose the 4. 8x is equals to 60 minus 4 is equals to 8x is equals to 56. Then we will divide both of these sides by 8. Therefore, we get 8x by 8 is equals to 56 by 8. Hence, the answer is 7. We will solve the questions in similar fashion. So students, this brings us to the end of the chapter. We have learned a lot of interesting things and qualities of an equation in this chapter. We have learned how to put the expressions in the variables, how to equate the values, how to get the solution of these equations. We have also learned to do the balancing of LHS and RHS as well. We have learned the balancing of equation by adding, subtracting, or by dividing both of the sides by certain numbers. We have also learned the special task of transposing, which means moving to the other side. By this, we can solve these type of equations very easily. Also, we have learned the technique of doing the mathematical operation for adding the same numbers on the both sides, and we have learned the usage of these equations in our daily life situations. I am sure you will use this knowledge in your day-to-day life, and also you will practice all the questions in the exercises mentioned in your textbook with thorough hard work and honesty. Till then students, I will take your leave. Bye bye.